Oxidation is a fundamental chemical process that can be understood in two ways. Historically, oxidation was defined as the combination of a substance with oxygen, such as when iron rusts to form iron oxide, or when carbon burns to produce carbon dioxide. However, the modern definition of oxidation is broader. It refers to the loss of electrons from an atom or molecule. For example, when sodium loses an electron to become a sodium ion, this is an oxidation process. Understanding oxidation is crucial for comprehending many chemical reactions in both laboratory and everyday contexts. The electron transfer mechanism is the heart of oxidation reactions. When an atom undergoes oxidation, it loses one or more electrons, which causes its oxidation state to increase. For example, sodium metal has an oxidation state of 0, but when it loses one electron, it becomes a sodium ion with an oxidation state of +1. Similarly, magnesium loses 2 electrons to form a magnesium ion with an oxidation state of +2. Understanding oxidation states helps us track electron movement and predict chemical behavior. The rules for determining oxidation states include: free elements have an oxidation state of 0. Monatomic ions have oxidation states equal to their charge. Hydrogen is usually +1, and oxygen is usually -2. Oxidation and reduction reactions always occur together as redox pairs. When one species loses electrons through oxidation, another species must gain those electrons through reduction. Consider the reaction between zinc and copper ions. Zinc loses 2 electrons to form zinc ions, while copper ions gain those same 2 electrons to form copper metal. We can break this into half reactions. The oxidation half reaction shows zinc losing electrons, and the reduction half reaction shows copper ions gaining electrons. In this process, copper ions act as the oxidizing agent because they cause zinc to be oxidized, while zinc acts as the reducing agent because it causes copper ions to be reduced. Understanding these electron transfer processes is fundamental to predicting and balancing redox reactions. Common oxidizing agents are substances that readily accept electrons from other species, causing them to be oxidized. Oxygen is the most familiar oxidizing agent, essential for combustion and cellular respiration. Hydrogen peroxide is a powerful oxidizing agent used in bleaching and disinfection due to its ability to break down into water and oxygen. Potassium permanganate is an extremely strong oxidizing agent, recognizable by its deep purple color, commonly used in water treatment and analytical chemistry. The halogens, chlorine, bromine, and iodine are moderate oxidizing agents with decreasing strength down the group. Chlorine is widely used for water disinfection and in swimming pools. These oxidizing agents have diverse applications, including combustion processes, bleaching and cleaning products, water purification systems, and industrial synthesis reactions. Understanding their properties helps predict their behavior in chemical reactions. Balancing oxidation-reduction equations requires systematic approaches to ensure that electron transfer is properly accounted for. There are two main methods: the half-reaction method and the oxidation number method. The half-reaction method involves separating the overall reaction into oxidation and reduction half-reactions, balancing each separately, and then combining them with proper electron balance. Let's work through an example using potassium dichromate and iron sulfate in acidic solution. First, we identify the oxidation state changes. Chromium goes from +6 to +3, while iron goes from +2 to +3. Next, we write the half reactions. Iron loses 1 electron in the oxidation, half reaction, while dichromate gains 6 electrons in the reduction half reaction. To balance electrons, we multiply the iron half reaction by 6. Finally, we combine the half reactions and balance the remaining atoms and charges. In acidic conditions, we add hydrogen ions and water molecules as needed, while in basic conditions, we use hydroxide ions and water.